My name is Hooman. I'm the VP of Technology at Fastly. We are a CDN company, as you heard earlier. That's the last time I'll talk about Fastly. I'll try to make this be as unbiased as possible, but obviously I work for Fastly, so there's going to be Fastly things that'll leak in there. I'll try to point those out, but generally everything that I want to talk about today is something that you can apply to any CDN if that's a technology that you're interested in or playing with. How many people know what a CDN is? Great. And I'm really excited that all the Fastly people raise their hands. Okay, so for just a quick review, CDN is a global network of HTTP caches. It helps deliver content closer to the users. It helps you do some offload. A network map usually looks like this. If there's continents here, it's white on white. That's funny. I purposely chose not to show the black one. So if you could at all see it, this is, you'd see that the map of the world would be there. Our goal is to be in all the places that Sergey wants web performance meetups. So that's ultimately what this map is going to look like, hopefully like Sergey's web performance map. So this is what, every CDN will have a map that looks like this, right? And the idea is to get caches out close to the user, serve content close to the users, and hopefully do a lot of offload for your origins. I'm going to start with a little tiny story. So about a month ago, we had a dinner in London, and The Guardian spoke, and The Guardian was doing a presentation on how they use the CDN, how they use Fastly specifically. And there was an interesting slide in there, which was this. And what this is it's a tool called Riffraff, which is an open source deployment tool that The Guardian has. And Patrick was talking from The Guardian, talking about what their workflow looks like, what is the sort of stuff that they do. And something in this slide really caught my attention. And it was this number right here, that essentially they were on version 1359 of their CDN configuration. That really caught my attention because what it meant to me was they're kind of using their CDN like just another part of their application. They were deploying to it like they would to any other part of their application, and it was a normal part of their deployment flow and their workflow. That was really interesting to me because it meant that maybe we should start thinking about CDNs a little bit differently than we have in the past, and maybe they should be fully integrated into our applications, and we should be sort of extending our applications to the edge with CDNs, which is sort of the genesis of this idea of extending our applications to the edge. So to get into that and talk about what that actually means and how it could help you down the line, a slight tiny history lesson is probably a good idea. So in the past, we had old school CDNs, or what we call classic CDNs. What do these guys do? They were kind of seen as a black box service. There was this like magical black box out there that you subscribed to, and they got your content on the edge, and they served it to your users, and they were great, and that's the way you were comfortable using them. Making changes on them sucked. Usually it involved making phone calls and engaging with professional services and going through a rigmarole to make changes. There was very few, if any, real-time interfaces, and by that I mean configuration changes were not necessarily real-time. There were no APIs. That has definitely gotten better over the years. Again, lots of professional services, and they were pretty good at caching content, but really crappy at uncaching content. That's a topic that we're going to come back to much later. I just throw it in there for now, and then we're going to come back and talk about this extensively. They also had a very interesting way of looking at your content. Some of them still do. Basically, it was a straight divide down the middle. Your content is either static or it's dynamic. And if it's static, it's cacheable, and if it's dynamic, it's not cacheable. That's kind of what they prescribed as the way to look at your content. So what does that mean? It means if it's static, you can slap one of these guys on there. So cache control headers for HTTP, you've probably seen this before. It's a way for you to tag your objects through HTTP headers to tell the CDN how long it should cache it for. This is what you do to every static object that you've ever cached anywhere. Hopefully you've done that many times. And your max age, the number you pick for the expiry of this object, is something that you kind of know ahead of time and have an idea of how long something is going to be valid for and not stale for. This is what you do for your static content. For your dynamic content, this is according to the old school. For your dynamic content, Basically, the CDN says, well, if it's dynamic, I can't cache it. I got to serve it from origin. So I'm going to provide for you a bunch of technologies that get content from your origin to your users quickly. What does that mean? You've probably heard of a technology or a suite of products called DSA, Dynamic Site Acceleration. Basically what it means is that your clients get sent to CDN nodes that are near them, and then from there to the origin, there's a whole bunch of cool TCP tweaks that make that delivery be as quick as possible. This is an optimized set of connections from the edge to your origin. Or better yet, we're going to send the client to a CDN node near you, and then route that traffic from the CDN on this side to a CDN node near the origin, all the way to origin. So the largest chunk of this transfer is going to happen over an optimized connection that has cache nodes on both sides. This is sort of how the CDN sort of divided the content. So it's either static and we can put cache control headers on it because we can predict how long they're going to be cacheable for, or they're not static and they're dynamic and we're going to do stuff like this to deliver it from origin very quickly. These technologies are fair technologies, good technologies. There is still a big need for technology like this that gets stuff that is absolutely uncacheable from the origin to your clients. But over time, things changed. So it's possible that at some point, if you were to subscribe to some of these old school CDNs, you had a conversation that kind of looked like this. You're on the left, you're red, and the CDN guys are going to be over here. You say, look, I have a piece of content, and by your definition, it means that it's dynamic. But you know what? It's kind of static sometimes. And the CDN responds with, great, static. I know static. We got to put cache control headers on it. How long is it static for? And you say, I don't know, sometimes a little bit, sometimes a lot. I can't predict it. It changes all the time. And this sort of threw old school CDNs into a bit of a loop. So they responded with awe, and then they tried to change the subject. You were probably onto them and said, don't change the subject. I need to cache this thing. This thing is going to be static for certain periods of time. And they would do something like this. Okay, let's cache it for half an hour. You cache your images for a year, you should cache this thing for half an hour. And then you say, no, it's going to change faster than that. And they say, well, about 10 minutes. And then you're on to them. You say, are you just guessing? And they say, no, they're actually trying to figure out what your tolerance for mistakes is. Now, this is obviously an imaginary conversation, as magnificent as that animation was. I know it's award-worthy. But this is the idea. The idea here is that the nature of content has changed a bit, where it can't necessarily fall into two categories, and static no longer means predictability. We're going to come back to this later. If you tried to do something like this, what it would lead to is guessing at expiries. And if you guess at expiry times, one of two things will happen. Either you'll have really bad caching, because you decided to put a 5-minute expiry on something that was sometimes static for days at a time, or you got terrible anxiety because you put a cache header, you put caching times on something that was longer than the content was going to be actually valid for, and you had to deal with stale content. So let me give you a good example of this. This is a real example. We were talking to a news company who had their sort of dynamic content that was their HTML that they thought was dynamic. They decided to say, we kind of want to cache this for a while, and they put a 15-minute cache timer on it. So cache control, max age equals whatever 15 minutes is. So one time they published a news story, and after about, actually I think it was about Britney Spears, and after about 3 minutes, they realized that they actually had published something erroneously. So this thing with a 15-minute lifetime was now on the CDN, and they couldn't get it off of the CDN because it was published, and it had a 50-minute timer on it. So for the next 12 minutes, they were basically crapping their pants because they had an erroneous story floating out there, and this is the level of anxiety that they had to deal with. So when I say it's terrible caching or terrible anxiety, it's this. It's essentially tolerance for mistakes. We're going to come back to this story later because it's going to be a character in our story. Today, things are a bit different. We've been influenced by clouds. We like having modularized applications. We like having a lot of control over our applications. Our DevOps people, because they're so cool and DevOpsy, and that's really buzzy, like programmability. They like APIs. They like to have control over the application. They like programmatic interfaces, so they want configuration to be quick, real time. There's some content, like we just talked about, that is not predictably cacheable. Ultimately, this ends up being your content, and because of the way we've developed applications in the last few years, we want that control over over our content. And because it's our content and we want that control, we want this interactivity with any service that we use. And the point here is that CDN should not get a pass on this. So the black box method or the black box thinking that CDNs used to be sort of fall under is no longer good enough, because they should be part of your application. So what does this all mean? Well, I think of it as sort of a three-silo problem or a three-silo discussion. There's three elements or three factors or three components that are important when you consider this idea of taking your application and integrating it with an infrastructure like a CDN that you're using. I have cacheability first, because caching things is a big deal with CDNs. That's one of the main reasons you're using them, to give you the performance that caching brings you. So cacheability is one silo, if you will, one column, one pillar. Control and visibility are the other two. We're going to talk about all these three things, although I'm probably going to spend a little bit more time on cacheability. The recurring theme here, as I go through all these things, is that the idea here is that this is a dominion over which you should have control and rule over, because it is your content. If it's your content and using a CDN to publish your content to, and it's part of your application, you should have full control and full say over what happens to your content on that CDN. That's going to be a recurring theme as I go through all these things. Okay, let's start with cacheability. So when we talk about having this level of control over the content that you cache and over the caching of that content, what does that mean? Well, there's a whole bunch of categories. Let's talk about a few. Traditionally, when it comes to caching anything, CDNs or otherwise, the cache key, the thing that identifies uniquely an object, is the URL. And that's usually what everybody defaults to. However, you may want to cache things based on other criteria. For example, you may want to cache things based on geolocation. You may want to cache things based on user agent that is normalized. Like you want to serve a different piece of content to Firefox than you do to Chrome. You want to serve a different piece of content to IE that you want to serve to Chrome, because Chrome is more modern and IE isn't, and et cetera, et cetera. Mobile users, you may want to cache a different piece of content to your mobile users than to your desktop users. And these are things that you want control over. So if you were to granularly cache those things and say, I want my cache key to not have just the URL, but also the user agent in it, that's an example of how you take over the caching rules that you have for your content. That's one example. There's more, though. When you use a CDN, since the CDN's one of its primary roles for you is to cache things, you should go in with a cache everything attitude. You should have the ability to cache as much as you want on the CDN, and you shouldn't be necessarily falling under these traditional definitions of static and dynamic and what you can cache and what you can't cache. So the CDN should be able to give you all the tools that you need to cache as much as possible, because the higher cache rate that you have on the CDN, the better things are for your application, for your users, for your performance, everything across the board. So that means that we should expect really high cache hit ratios, and that means that we should be able to cache without this cache control anxiety that we talked about earlier. I'm going to talk about those two things now. First, I want to talk about cache hit ratios. You've probably all heard about this term, cache hit ratio, and traditionally this has basically been defined by this formula. So this is how CDNs have generally called this defined cache hit ratio as, which is essentially 1 minus the number of requests that make it to origin versus total requests. So if you have 100 requests that enter the CDN and one of them makes it to origin, you have a cache hit ratio of 99%. This is how it's traditionally been defined. So what does that look like? It looks like this. So here's a CDN, here's your origin, and here are your users. And your users come into the CDN here, and they enter the CDN. They're served from one of the caches of the CDN, and you look at the origin, and if you measure things as to how much of those requests sort of squirted out of the CDN to the origin, that's how you calculate your cache hit ratio. So number of requests to origin divided by total requests is your cache hits, and 1 minus that is your cache misses, and 1 minus that is your cache hit ratio. But there are some nuances here that have sort of gone unnoticed over the years. So let's talk about what a cache hit looks like. So here's a cache. Here's a cache at the edge, and those users are going to come in and hopefully hit this cache. The way that happens is usually you open up a TCP connection and then you make an HTTP request. The TCP connection is between your client, be it mobile or desktop, and the stack, the OS essentially on that cache node, the TCP stack on that cache node. Okay, so you make a TCP connection, then you make an HTTP request for the object that you're fetching. Now, the HTTP engine in this cache is going to look at the HTTP request and then decide to serve it for you. But look at what happens now. There's a huge difference between serving that content from the memory of that cache versus the disk from that cache versus a cache deep in the network. What ends up happening is that object can actually be served back to you from any of these components. And there's a huge performance difference between how far towards the edge the content is actually coming from, right? And this is essentially what I call, nobody else calls it this, heat of the temperature of the object, right? The closer the object is to the edge, the more likely it is that it's really hot. It's being fetched very, very frequently from the users. And as it gets less and less hot, it becomes cooler, and it's likely being fetched a lot less from the user. So this is the temperature of the object. What ends up happening, because the CDN cache can't cache everything over here on this one little cache server that they may have, is content ends up essentially falling out of the caches here. So it'll fall out of the memory first, then it'll be on disk, it may fall out of disk next, and then it may get served from some big honkin' middle tier cache. And that is a big difference in performance. However, the CDN still calls that whole thing a cache hit, right? So when you think about cache hit ratios, if all of these hits are equal, then yes, we can use that formula as a cache hit ratio. But we just saw that for performance, it's a completely different story because it's very, very dependent on where your content is coming from. So whereas this is the old way of calculating cache hit ratio, maybe it's better if we change that formula and say the cache hit ratio should actually be the number of hits you get at the edge versus total requests at the edge, which is essentially hits plus misses at the edge. So if I get 100 requests at the edge and I serve 99 of them, then I would like to consider that a cache hit ratio versus how much of it got served from the entire CDN at all. Now, to be honest with you, I actually kind of want both because this is a pretty good indication of offload. This particular definition tells me how much of the request made it to my origin. And one of the reasons I use a CDN is to not have a lot of requests get to origin. So this is actually a pretty useful metric. And I would expect to see this from my CDN. But for performance, this is a much better metric because it's telling me how much of the responses are coming from the edge.
The answer to that
and the
question.
reason I deployed a CDN in the first place
literally
is
is going to feel like this was rehearsed. It was not. I'm Hooman, by the way. We've never met.
Okay, so this has, if I may do a precursor to answer this question, a huge effect on long-tail content. So what's long-tail content? For those of you who aren't familiar, essentially long-tail content is content that's cacheable but seldom fetched. So it's stuff that you want cached, but your users aren't necessarily fetching that often. This is long-tail content. What falls under this category? Very personalized stuff. Imagine family photos. Your Instagram account, for example. Those are pictures that you take and only your followers are ever going to maybe see. So these are things that there's lots of them, and they fall under this long tail category. They're fetched seldom or maybe in bursts, but they're definitely cacheable objects. There's a huge difference in performance of long tail objects if they're not served from the edge of the network. So to answer the question, I'm going to show you some actual numbers. Now, this is a CDN that I'm going to not name, so an anonymous CDN. What I'm going to show you is essentially the difference between TCP connect times and HTTP fetch times based on the temperature of the object. Okay? So what you're seeing here, I'm going to show you three different kinds of objects. A really popular one, so imagine an image on a home page on a very popular site, versus, I don't think that's an actual term that people use, so I'm calling it medium tail. Versus long tail. So medium tail is something that's fetched once an hour, and long tail is something, in this case, that's fetched once every 6 hours. So that object is being only fetched once every 6 hours, so definitely being fetched seldom, versus this guy that's being maybe fetched many times a second, a minute, whatever. Now, What I have here first is the TCP connect time. And what you're noticing is that they're actually kind of all the same, right? If I gave you the numbers, it's 14, 15, and 60 milliseconds. All of them basically within a millisecond. This is from, these are actual numbers from catch point tests, catch point last mile tests across the planet. In case you don't know what that is, I think we've had catch point here before, right? Essentially, they have these boxes they ship to people's homes that have the entire browser stack on there, and they'll run tests for you from behind real routers, which is an amazing way of looking at actual user performance because you get the real last mile latency and bandwidth limitations. They're a great service for stuff like this. They also pay you to host one of these boxes. So if you're interested, contact them. I'm sure Sergey has the information. They pay your internet bill if you host one of these boxes at your house or behind your router. Anyway, so what I've basically plotted here is the TCP connect time. If you remember back to our graph, what's happened here is the browser has made a TCP connection to the server. And I would expect all of these to be the same because it's the same machine, and it's the same OS, and it's the same TCP stack that the client is connected to. But I'm really interested in, to address the question, I'm really interested in what the performance is like for HTTP as I fetch these different types of objects, and look at what happens. So the popular object is being fetched, let me put the timers on them. The popular object is being fetched in about 19 milliseconds, which tells you that it's a mixture of things coming from memory and things coming from disk. The medium tail object is being fetched at 26 milliseconds, almost 70%, if I'm doing the math right, more than the connect time, which means there's a higher ratio of the object coming from disk than from memory. And the super long tail, the 6-hour guy, is twice as long. It takes twice as long to make to fetch it than it is to make a connection, to make a TCP connection. What that's telling me is this is likely coming only part of the time from the actual server itself, and a lot of time from somebody behind the server, deeper in the network, a bigger silo, bigger chunk of capacity that CDN has offered me. This, just so you know, this is over a month's worth of testing. That's 77,000 data points for the first one. And because the second two tests are happening less frequently, it's less data points. But that's significant enough to see the patterns that are actually emerging here. Does that answer your question? OK, so this is what happens if you're not addressing the long tail problem, if you will, or why we care about a different cache hit ratio formula than the one we've been sort of fed over the last few years. And this is why if you ever are thinking about using CDNs with any sort of data that falls under any version of a tail, these are the sorts of things that you should really look out for, because our natural tendency, and I've seen this hundreds of times from clients and partners, is to only test this. If you've ever talked to anybody that's tested a CDN, what they've likely said is, I just took a thing from our homepage and I ran 100 curls to it. I pinged them to it. I ran some testing mechanism to test that one object from the homepage. What you've done is you've essentially tested something very popular. What's really interesting is what happens here. And the gap between these two lines is essentially how well that CDN handles longer and longer tail content. Isn't this a lot better? If you had this from your CDN versus if you had that. Now, I will say, just before you jump down my throat, this is not Fastly, and this is not Fastly. Neither of these are Fastly. I will also say that we look like one of them. Maybe the second one. Okay, yeah. The question is, why is there a difference between the yellow line and the red line? Why aren't they on top of each other, right? Is that generally the question? So I would say that if you're testing this scenario between CDNs, or if you're evaluating, you should look for lines that are on top of each other. That's essentially what you should be shooting for. I'm not entirely happy with this either. I'm really happy with that. Like, if this is what I'm going to get, that is a very good next step from, like, when my popular content and my 6-hour tail content are performing similarly, that's a pretty cool thing. But I actually would want these lines to be more on top of each other. And what's probably happening is twofold. One, I've actually seen this quite a bit in these particular test agents. So there's something in the tester itself that I think has probably a different timer for the TCP timer versus the HTTP timer. I think that's a little bit of it. And the second part is essentially architecture. And it depends on the architecture of the CDN. And like I said, neither of these are fastly, so I'm not exactly sure how this particular CDN has built their edges. But essentially what you want is an edge that minimizes the distance between those two for all content types. This is what you're looking for. And this is just all this does is it points to the way a CDN was architected and is deployed. And that's insight to that, essentially. Yeah, the question is, the very good question. Yeah, the question is, are both tests comparing the same object? So not the exact same object, because these are two different CDNs, and basically what I did is I found a customer of theirs, and like a Alexa 1,000 customer of theirs, of each of theirs, and just tested the same object over and over again. So the assumption is that it's a representative image or an object for a representative customer. Now, it's very possible that I picked a really crappy customer that got a really crappy map, for example, from that CDN, but I went through a bunch of things to make sure it was as clean as it could possibly be. So it's not the exact same object. So I didn't sign up with all the CDNs and test the same object. Yeah, the idea is, and this essentially, I took content that is essentially on a big customer's homepage and turn it into long tail content with query parameters. That's a thing that I had to test configuration. A whole bunch of things went into getting a close enough representation of what these CDNs are doing. And you see the difference, you can clearly see the difference. That's a very good point. The point is that the TCP time here is longer than the first one that I showed, right? That's essentially a footprint. So how well you do on the yellow line is your footprint, is how well distributed you are everywhere. The catch is, on a web page, you guys all know this because you're TCP performance gurus, right? You're coming to the meetup. On a web page, to a domain, a browser, to a single domain makes 6 TCP connections and then makes hundreds of HTTP requests. So even though I'm interested in the yellow line, I really care about the red line because that yellow line is happening 6 times on a page, probably across an entire visit. And this thing, the red line, is happening hundreds of times between the beginning and the end of the transaction, end of my session. So basically, all I use the yellow line for is footprint, an indication of footprint, and how close they generally are to the user. So very good point. The point is, and it's a valid one, the red line is time to first byte. I don't know if you can see this. It says wait time. That's a term that CachePoint uses for time to first byte. I purposely picked objects that are all less than 1500K, so they fit in one single TCP packet. So there's no issue of multiple packets coming down the wire. Any other questions on this? Yeah, absolutely. I'm really glad you mentioned it. I don't want to say SSDs because that's a Fastly thing, but I'm really glad you mentioned it. So yes, that could be a contributor here. So actually, the diagram that I showed you earlier with memory disk, there should actually be 2 disk diagrams. There should be a spinning disk diagram and an SSD diagram because you're going to get different performance profiles for those guys. So again, it's all architecture. And what this shows me as I evaluate different CDNs as part of my job, because I work for a CDN, so I need to know what the others are doing, is it's telling me about how they're building their edges, how well their footprint is widespread, and how they're serving content when it comes to performance. So that's a very good point. Totally, SSDs would make a difference. So that's long tail content. There was another component in caching that we talked about earlier, which was this notion of dynamic content. If you remember, we said that CDNs have been basically telling us that our content falls into 2 categories. Either static, which is cacheable, or dynamic, which is uncacheable. And it's always been this simple. You either fall into category A or category B, no room for gray area. So what our content probably looked like was this years ago. We had a whole bunch of static objects, images, CSS, JavaScript, et cetera, and we had some dynamic content, our root HTML, maybe transactions, credit card things, and most of our content was static. And this, a very simple CDN, 10 years ago, this was a very good candidate content profile for that CDN. Then over the years, our apps got smarter, much smarter, and under the old definition, we started growing in dynamic content. We started doing things like geo-targeting. We started adding more logic to our applications to serve different types of content for different people. Mobile showed up in our world, so we had to serve a different type of content for a mobile browser than we did for a desktop browser. All that logic was burdened at the origin. And by this definition, more of our content became dynamic. We still had a lot of static content, which were those images and JavaScript and all the things that could be cached for a while. Now, this may be different for your individual sites, but essentially the point is that what traditionally has been called dynamic got larger and larger and larger. The truth, however, is that it's not black and white, and all the things that require application logic don't necessarily fall into this category. There's actually 3 different types of content. There's the static content that we've talked about already, images, JavaScript, things that you can predictably say will be static or can be cached for this amount of time, things that you can control with cache control headers. Then there's the dynamic stuff that you can never cache because it will never be the same between 2 different impressions. So credit card transactions, maybe shopping carts, logins, things like this. And then there's this whole other category that's been sort of growing over the last few years, which we call event-driven content. What's event-driven content? Event-driven content essentially is content that looks dynamic, but it's actually static. The catch is it's static for unpredictable periods of time. This is what that conversation, that ridiculous conversation that I showed you earlier was trying to pinpoint. You can't predict it ahead of time. It's going to be static, but you don't know how long for. There's a lot of examples of this. Blog comments. You make a blog post and you have comments that are sitting down there. You have no idea at what frequency people are going to be commenting on your blog. What else is there? Wiki pages. You make a wiki page and it just sits like that for 2 years, and then all of a sudden something happens and it gets edited 300 times in a week. Scores, sports scores, stocks, all these things fall under event-driven content. When I say event, I don't mean like an earthquake or the plague. It's something that happens administratively, user-generated, some sort of application event that occurs that makes the content change. So that's a kind of content that has kind of gone unnoticed in the world of CDN, and the tools to actually be able to do interesting things with this haven't really been around. I'm going to talk about those tools in a second, but a quick review. We have 3 types of content that we defined so far. So this is our static content that change infrequently. We're very good with cache control mechanisms to sort of govern how long things can be cached for, and images and JavaScript are a perfect example of this. Then we have dynamic content, which we can't cache at all. They have to go to origin every time, and technologies like DSA are very good ways of optimizing the delivery of these objects to you. Like we talked about earlier, Ajax, credit card transactions, logins, things like this fall under the dynamic category. And then there's this category of event-driven content, which is actually static, but for under very unpredictable conditions. You can't tell ahead of time how static or how long something's going to be cacheable for. And cache control headers are no longer a valid mechanism for caching them. And truth be told, the HTTP protocol didn't give us the right levers to cache this kind of objects. So we need new ways to do things here. Remember that news story that I told you earlier, the Britney Spears story that went out for the 15-minute expiry? That is exactly what an event-driven piece of content is. It went out, it had 15 minutes of expiry, and something happened. In this case, it was an oopsie, a mistake, that made that content no longer static, changed that content. And we need tools and mechanisms to deal with those types of content. Now, how do we cache those kinds of content, what we are now calling event-driven content? It's not really an easy thing, because the old school CDNs haven't really given us the tools or the mechanisms to deal with them, and they've kind of put them in the dynamic category. And if they put that kind of content in the dynamic category, we talked about this, you either get bad caching or you get panic attacks, because when you make mistakes, you have no way of getting yourself out of those mistakes. You may not know the expiry of these objects ahead of time, the way you would with a static object, but it is very likely that your application knows when something changes. A user event triggers something. An administrative deploy event triggers something. That's all stuff that your application knows. So the strategy for caching content that falls under the event-driven category is actually quite simple. Is cache them normally like you would with any static piece of object, and then uncache it when it changes. We talked about uncaching earlier. This is what this means. And in the world of CDNs, we call this purging. This is what purging is. Purging is getting something off of the CDN. It's usually accessible through an API. It actually has to be accessible through API, because if your app knows about it, then you can programmatically get to that API and get it off the CDN quickly. It needs to be granular, so you have to be able to purge either one object or groups of objects together, or the whole site if you're deploying a brand new thing. You have to be able to get have granularity in the way you purge things, and most importantly, it has to be instantaneous. So let's go back to that news story again. There was a news story, 50-minute expiry, that they decided to have a 50-minute expiry. They pushed it to the CDN, and then something happened where they realized there was a mistake. It would have been really easy to fix the problem if they had instant purging of that object available to them, because they would essentially uncache it from the CDN immediately. It has to be instantaneous. Otherwise, it's not really going to be the mechanism we need to cache this type of content. So what does instant purging give us? Instant purging gives us the caching of event-driven content for a way for us to programmatically invalidate this type of content. And what happens is, as things change, as objects change, as content changes, we just purge to purge the CDN of that object, and we're good to go. What does instant mean? Well, it's not 10, 12, 15 minutes, and this is actually what traditionally CDNs have given us, is multi-minute purge times. It's been a huge problem because it has totally eliminated the caching of event-driven content from CDNs, because these purge times are just not good enough. It's definitely not a quick acknowledgement. You can't send a purge to a CDN and have the CDN say, got it, and then not purge for 30 minutes. That's not good enough, because that still keeps the story out there. It's got to be less than a second. We think it should be in the, at most, 100, 200 millisecond range. And it has to be deterministic, and it has to be predictable. That's a lot of talking. Let me show you an example. So I'm not picking on WordPress, but I'm just using it because WordPress is a CMS. So this is an example. This is a real example, but I'm not necessarily saying there's anything wrong with WordPress. So here's the way you post a blog on WordPress. You go to WordPress, you go to your server, and you publish you write the blog and you publish it. Then you put a CDN in front of it, and your CDN user comes in, makes a request. That request comes all the way to your server, because at any time you may be editing the content of your blog, or people can come in and comment on it. You really don't want this thing to be cached on the CDN, because you have no idea when you're going to change your mind about something, or when your users are going to come in and make comments. So what you do generally, what you did generally, is you would basically tell the CDN not to cache this. Now what would happen, and you're all being web performance gurus, you're all very familiar with this, is this would happen to your waterfall. Because that blog root HTML had to go back to the origin every time, you had time to first bytes that were terribly, terribly long. Now, again, I'm not saying all WordPress is like this. This particular one, I just happened to pick one. It could be any CMS. We're talking conceptually, but this one was really shitty. So what happens after the fact? Now, we have this instant purge function, let's say, in our tool set. What happens now is you go back, you post your blog post, and when the CDN fetches it, because of your users, you serve it with a cache control header that says cache it for a long time. Now, totally long time is not a legitimate cache control header. Don't ever use it in a cache control header. If you do, please write me, because I will use you in my next presentation. So you serve it to the CDN and say, hey, CDN, please feel free to cache this as you wish. And the CDN caches it and serves it back to the clients. That's going to keep happening. Your next client, your new users come in, they're going to fetch it from the CDN, awesome. And then sometime later, something happens here where you edit the post, or you have users that come in and comment on it, and you say, cool, a change has occurred. I'm going to purge that thing from the CDN. And once you purge it, the CDN goes, boop, and it just disappears from the CDN instantly, which is the key right there. And then after that, the next request that comes in, the entire cycle begins again. That's a really simple example of how instant purge can help you deal with event-driven content. That blog post was an piece of event-driven content, because you had no idea beforehand when it was going to change or when it was going to be invalid. The moment it became invalid, the moment it changed, you told the CDN that it changed, and everything was cool. Yeah, it depends on what you prefer. I'm talking about purging it altogether, because that validation to origin still requires a round trip, and I would rather not have the round trip. But if you are uncomfortable with that, you should look for both mechanisms for your CDN. It's faster, but nothing is as fast as serving it from the edge without going to origin. Only on the first get. On the first get.
Yeah, on the first get.
So what you're saying, I see what you're saying. You're saying, no, but remember, that something's changed. The 304 is not really an option anymore, right? because the reason you sent the purge in the first place was because something changed. So there's no point to validate. Normally, validation would be faster than a full fetch, but what's happened here is the object at origin's actually fully changed. That's the reason we sent the purge in the first place. So even if you sent the validation in, you would get the entire object back because the reason you sent the purge in the first place was to get rid of it. But there should be a mechanism that says purge to stale versus purge to delete. Yeah. There should be both mechanisms, yeah. Okay, and everything gets cached, everything gets served from the edge after the content is refetched from origin. Now I'm going to do a slightly more complicated example. I'll stop at the end if you have questions. The only reason I'm doing this is this was from an actual customer discussion, and I really love this example because it's a very good application of instant purge, but it's a little weird. So let's see if I can explain it well enough. Imagine that you are a provider of a product that is deployed via JavaScript. So you're an analytics company, or you're a rum company, or you're an ad company. The way your product is deployed is you put a little JavaScript tag in a page. That's how your product works. And what happens is your users come to a portal and make configuration changes, and those configuration changes, for which this is the universal symbol for, those configuration changes change the nature of that JavaScript, basically create a new JavaScript. Imagine that you're that customer now, or that provider. Now, what happens is on customer1.com's website, you have put your tag, and you are thirdparty.com. So what the customer does is it makes a request, it gets to the CDN node, it's a request for that job, for their JavaScript, so customer1.js, which you generated here after they did their configuration. And there's a refer, so you know which version of the JavaScript you're sending to them because of the URL, and the refer is for whatever, identity verification. This comes to origin, and you serve this with a max age time of 60 seconds. Why do you do that? Because you have no idea when your customers are going to come in to change configuration. And you're really afraid of having an old version of their JavaScript live on the network. So the only way you know how to handle this is to put a very, very low cache control header on it and serve it to the CDN. CDN says, okay, and every customer, every user that comes in and requests that JavaScript will also get it with a max age of 60 seconds. What happens after a minute? New user comes in and makes a request to the CDN. The object has been invalidated or is stale, and you have to go back home. You do a validation request back home in this case. This is a small response, and your CDN says it hasn't been modified, use what you have in your cache, and everything is cool. However, this required a validation to origin, which takes time. But you did this whole thing because you were afraid of serving bad JavaScript to the customers of your customers, right? You didn't want customer1.js to be outdated, to not reflect the changes that your customer made 30 seconds ago. This is how you did it before. How does Instant Purge help this? So watch this. Now, this is still before. Now you have the request come into the CDN node, comes all the way to the origin, you serve it, but you have different cache control headers now. You still have a 60-second cache control header because that's going to go all the way to the browser. You want the browser not to cache it longer than it should because you have no control over that guy. You have control over the CDN though. So you use this other header, smaxage, which that's a month. That's a month's worth of seconds. Anybody know what smaxage is? Great. So for those that don't, smaxage is a mechanism that HTTP gave us for controlling cache expiry on shared caches. The S stands for shared. Don't ask me why there's a hyphen here with smaxage and a hyphen here with maxage. I have no idea. Not English majors wrote the draft. But smaxage essentially says, if you're a cache, I want you to have different TTL heuristics than if you're a browser. That's how you govern it, like this. Now, when it gets served to the browser actually ignores that header and only uses the max age timer right here for how long it caches it for. Now what happens after a minute? A new user comes in and makes a request. The object hasn't changed. Nothing's changed after that minute. So somebody comes in 3 hours, and you still have the object sitting at the edge, and you serve it back to the client, to this new client. This happens many, 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 many times, and you have many, many happy users. After a minute, things are different. The customer, like let's say in 10 hours, your customer comes in and makes a config change. That config change instigates a purge command to the CDN. The CDN gets rid of it. the next request comes in, and the cycle continues again. So that is essentially another good example of how you can use instant purge to your benefit to get essentially control and, what's the best word for it? Granularity for caching out of your CDN. Now, that's a really good segue to the control concept. So again, we have three pillars, right? We had cacheability, we had control, and we had visibility. So instant purge is a really good example of control over your cacheability. But there's more. We want general programmability over our CDN, which means we should expect configuration APIs. We should have a programmatic interface to communicate and interact with the CDN. We should also be able to have logic at the edge. Some of the things that we may be doing at origin, we should be doing at the edge. And if the CDN gives us those mechanisms, we can do those. I'll give you some examples of those. I already talked about invalidation. That's what purging was. That's an API that your CDN should provide for you. Hopefully instantaneously, so you can do some of the cool things that we talked about. Configuration is simple, right? We want to do what the Guardian was doing. We want to have a configuration API that lets us programmatically change config and push config to our CDN. That's what configuration APIs are for. And control at the edge is actually kind of cool. You move some of the application logic to the edge and do some of the things that you would normally do at origin at edge. Now, at Fastly, we use Varnish, like Sergey said. So we have something called VCL. Any Varnish people out here? You guys know Varnish? Cool. Nice. So VCL, if you have never seen it before, it's basically a config language that reads like a script. So there's like if-then statements in the config language. But it's not the only way you can do this. Any CDN should be able to give you some mechanism to push some of the logic that you would have at origin to the edge and not necessarily have to go all the way back to origin to do some of these things. What do those things kind of look like, or what are they? Some examples where maybe there's some content that we can just generate directly from the edge. Manipulate HTTP headers, do geofencing, select different origins based on the requests, force a request to go SSL, serve stale content, use headers like stale while revalidate and stale while error to serve stale content and control how long we serve that stale content over. These are just some examples of running some logic at the edge of your network, being able to run logic that you would normally have at the origin but at the edge. Here are a couple of very simple and cool examples of edge-generated content. We have a number of partners that want to know which CDN node they're being connected to. So they'll make this request. In this case, it's like it appears to be a JavaScript request. And what happens is the edge actually returns a response in JSON format straight from the edge. This is a piece of object that was constructed and put together on this CDN node. I put the origin in this just to be polite. This is a totally originless example, application of a CDN. Here's what the VCL looks like. And again, this is just one example. It's the example that we use. But any CDN should give you a mechanism to do what I just showed you. Here's another cool example. You know these pages that do what's my IP address? Like you go and say, what's my IP address? You can essentially do that entire thing statically on a CDN if you had some mechanisms in that CDN. Notice that you make a request to essentially a JSON object with JSON, there's a JSONP function defined, and that's the response you get. Notice that the function that you defined in JSONP is actually included as part of the response. And what's in the response? You have Geo IP information, you have IP address information, everything that you would have had at origin generated by your geologic is now being generated from the edge. And it doesn't necessarily need to be this function, it could be any function, right? It could be something else. This is one example. So the example of something like this would be exactly if you were to build a what's my IP page. I'll tell you this, we have an internal application, we have an internal RUM collection application that uses this very model to collect IP and location data for customers that want to collect that sort of stuff. And this is just one example. There are dozens of things that you should be able to generate here work that you would normally do at origin that you don't need to do there anymore. Again, I put the origin here just to be polite. These are, again, fully originless applications. This is one example of things that you can be doing at the edge. I should have probably also included an example of choosing a different origin, which is logic at the edge, or manipulating HTTP headers, which is logic at the edge, or geofencing, which is logic at the edge, or serving a different kind of content for mobile than desktop, which is also logic at the edge. All those are things that you should expect from whatever mechanism is sitting here. You shouldn't need to do those things here. Finally, the third pillar is visibility. So the same way that we've talked about having full dominion over caching your objects, having full control over the edge of the network, be it in configuration control and configuration manipulation in real time, versus doing things at the edge and running some logic at the edge. The same way that we have those, we also should expect real-time visibility from our CDN. What's real-time visibility? It's actually simple. It's everything that falls on the analytics umbrella. So there should be an API for stats. That API should give you things like network stats, HTTP stats, what was a hit, what was a miss, what went right through, what was an error. And all these things need to be real time because you'd like to see things from your CDN the moment they're happening, the same way that you expect that from any other part of your application. Your CDN statistic dashboard should be, if you choose it to be integrated into your own application dashboard as just another component that you have a real-time lens on. It needs to be exactly the same way, and that's another good example of using a CDN as an extension of your application. Now, this doesn't mean historic data is bad. You should always have historic data, and hopefully your CDN will also give you historic data, but there's an emphasis on having real-time visibility and real-time analytics come to you. This also includes logging. So, you have a question? Real-time is real-time. Like the moment it happens, if you're logging, for example, and a request happens on the CDN, you should see that log in your syslogs within a matter of microseconds or seconds at most. It should be real-time. It should be as it's happening. No storing, essentially. Let's think about it that way. No storing should occur. Logging is another good example. So if you look at real-time logs, you should have a CDN that is able to stream those logs to you and replace what you would normally have as your access logs before. And to any endpoint that you want. Maybe you want to keep these things on S3. Maybe you want to have a syslog server. Maybe you want FTP. Whatever your mechanism is, there should be a way to get that content to you. I'm going to give you this is probably my favorite example of all that kind of uses all the mechanisms together. So this is going to use some caching control, less caching, a bunch of things about control at the edge, and definitely use real log files, real-time visibility. So this is beacon termination. Who knows what beacons are? Are we comfortable with beacons? Great. So for those of you that don't, a beacon is essentially a way to collect data from a browser and send it somewhere for collection. What happens is, let's say you're running a beaconing service of some sort, or you're running a beacon on your own site. You make a request to a beacon endpoint. It's just an object. It doesn't actually matter what that object is. What really matters is these query parameters, which are things being collected. If you've ever looked at Google Analytics requests, they're carrying a bunch of beacons, a bunch of query parameters like this. If you've ever used RUM, all that information is going back to the RUM server through a beacon. So beacons usually are collected at the browser. If you have a CDN that's sitting in front of your beacon collection mechanism, the requests are usually going through that CDN node all the way to origin. And the only reason you have an origin in this picture is so you can collect access logs. Because what happens is you respond to that beacon with maybe a tiny image, because it was like a request for an image. That image is actually not consumed by the browser at all. It's usually a hidden image. It doesn't really matter. What really matters is that you collect a whole bunch of access logs here and then do some analysis on them later. Because the actual contents of this response are totally immaterial, don't matter at all. So how can you do this exact same thing through the mechanisms that we've been talking about? Okay, like this. You make the beacon request, you make the beacon call from the browser to the CDN node. It still has the same query parameters. You respond straight from the CDN node. There's no reason for that to go to origin. Remember, the only reason it went to origin was so you can collect a log entry. That's the only reason I went there. So you can respond from the edge straight with either an image or, better yet, with a 204, which in case you don't know what that is, that's basically an empty response with no content. Tells the browser, thanks for coming, but I got nothing for you. It's a completely legitimate response. Doesn't matter where it comes from, but you generate that here. So this is, to your point, this is a good application of generating content synthetically at the edge. You send that back. The browser doesn't care. You don't care what the browser gets. But what you end up doing is you take that request and real-time stream it to some sort of endpoint that ends up being your collector. Again, this is an application that does not need an origin. And this is what we mean when we talk about using your CDN as part of your application. You can build an entire beaconing application with no origin, just using the CDN as the infrastructure to deploy it through. Yeah? The request is, right, and you fire the request and the response is immaterial, which is why from the CDN you just send it to a fallback. This right here, this bit right here is not an HTTP request, right? This is just a, this is syslog or the S3 API. Those are examples. But it's using the API. It's not the beacon going to, it's not using S3 as the origin. No, it's not blocking. The response already went back. Yes, the question is, how does Fastly do the aggregation of the logs, and is it coming to the endpoint from every cache node, or is it being aggregated somewhere? Do I understand correctly? So Fastly has a number of aggregators that work in real time. So one of the main reasons we do that is so you can have IP rules at your collector for who's allowed to talk to them. So there's a distributed set of aggregators that will do everything in real time. So it has a little bit of both. There's aggregators, but it's real time. There's no like save it up for a few minutes and ship it. It's all in real time. Yeah. Okay. Yes. Yeah. To do a batch write to there's with S3 because we use the SDK. It needs to batch up a few. With syslog, you can just send them one at a time. That's it. But with S3, we have to bundle it up a little bit. So there's a second or two delay. Yeah. Okay. I've been talking for a very long time. I promise this is close to the end because there's a slide that says summary on it. Basically, what we've talked about is having tools and mechanisms for your CDN to be part of your application. The black box model that we had before from CDNs, I don't know how much you've used CDNs, but the black box model, which was there before, is no longer valid, is no longer good enough because we expect the same sort of flexibility, the same sort of control from a CDN that we would from any piece of architecture, any piece of application, any piece of service that we use with our application. So because of this, we need really good caching. We need total control over that caching. We need total control over that uncaching, the same way that we expect control over the caching. We want very good control over configuration. We expect APIs. We want real-time visibility and statistics. And everything needs to be real-time and instantaneous because that's the only way we can use a CDN like we use any other part of our own applications. That's essentially what we've been talking about for 1 hour, 1 minute, and 30 seconds. That's the end. If there's any more questions, I'm happy to take them. Are there any more questions? So yes. The question is, what's the big difference between a CDN node and an origin? So a CDN essentially is deployed through a number of caching nodes all over the planet, distributed, and their job is to act as proxies. And they're primarily HTTP proxies, which act like servers to clients and act like clients to servers. Your origin is where you built your website. That's where your infrastructure is. That's where your logic is. That's where your application is deployed. That's where you do your coding, essentially. And then the CDN comes and fetches things from your origin and pushes it out to the edge to its cache nodes to serve to the clients. However, that CDN also should be smart enough to give you mechanisms to do things like we've been talking about. You should have APIs to communicate with it. You should have ways to purge things from it as quickly as possible. You should get visibility with statistics and logs and things like this. And all the assets in it are on like cdn.site.com. And cdn.site.com gets, through DNS, goes to all the CDN nodes. Or you can just go ahead and say www as pointed to the CDN and let the CDN choose for you what it caches and serves directly and what it goes to origin with. You can have that control with a lot of HTTP headers. So because they're a storage play. So they just store lots and lots of content that maybe multiple sites can use, or your site or many other sites. They're just acting as a storage service. To that point, for example, when S3 first came out, when CloudFront, which is Amazon's CDN, came out, it only could use S3 as its backend. Essentially, it was an extension of S3. The idea that they could use any origin, a custom origin, was a feature that came in like version 2 and 3. So you can think of CDNs as an extension of centralized storage, but we'd like to think of them as an extension of much more than just storage. They should be part of the application. Do the quick one there, do the slow one elsewhere. So again, I think this kind of comes down to an architectural question. Maybe some CDNs have a problem with a large set of rules and maybe others don't. I can again only speak for Fastly, but for Fastly we have customers that use our edge logic as essentially an ACL. So they figure out things for access control and they constantly push different versions of their config and have dozens and thousands of if-then statements in the logic. You don't need an each request. You do if-then statements through the config file, but you can separate your config file and have a config file that's just the if-then statements, have a config file that's a different portion of the, did I answer the question? Right, the question is, when you do the instant purge and the WordPress article gets purged from the CDN, the next user that comes in does have to go all the way to origin. That's this slide right here, right? He does have to go all the way back to origin. And even though that's just one user and that primes the cache for all the thousands of other blog readers that you have, which will come to your web performance blog post right after, there is still one person that paid the penalty. Is there a way to do a no user left behind? So that's the question. And it's actually a good one because there's a number of mechanisms that are being introduced outside the world of CDN to address this. And essentially it's the notion of serving, of a permission to serve stale content. That's essentially what it means. So I've been talking about instantaneously purging things from the CDN edge, right? And the moment that you purge, I've sort of assumed that the thing disappears from the edge. Now, you do have an option, or you should have an option for this purge command not to necessarily delete, and we talked about this earlier, not to necessarily delete this from the CDN node, but instantaneously make it stale. And through headers, which the standard defines two, one's called stale while revalidate, which is constructed just like max age. So it's an amount of time that you're allowed to serve a stale content while you do revalidation behind. And there's one called stale if error, which is how long you can serve stale content if there's an error talking to origin. Through those mechanisms, you are allowed for maybe some amount of time that you also have control over to serve stale content from here. And that means when you send this purge, you don't delete it, you just make it stale. And if you allow serving of stale content, you can still serve it for 2 or 3 users as you go and do the validation with origin. Fastly calls this a soft purge versus an instant hard purge, which gets rid of everything. I have no idea how other CDNs handle this, but that mechanism is very, very valid. And it's actually used very much across our user base. There's a lot of usage of stale while revalidate, and soft purge was in high demand, which is a feature we added actually recently. So it's a thing that's being used by users. It's a very good question. There is an alternative. There should be an alternative to instantaneously getting things off the CDN. Let me give you another example. Imagine that you have a very, very, very popular piece of content sitting on the CDN. And you decide that you want to purge it because you made a mistake. That Britney Spears story. There's a non-zero chance that if you purge it from every CDN node, you're going to create a DDoS for yourself at origin because everybody's coming to get the story and you just purged it because it was a mistake. So your origin is going to get hammered with these users coming in. It's a lot more efficient to make this purge instantaneously make the content stale, and then you keep serving stale content, you sort of buffer the load as you go back home and validate and bring the new piece in. So that's a very valid point, and it's a very valid mechanism. Is there such a thing as too much caching? There's probably such a thing as having too many layers of caching. I don't think there's such a thing as too much caching. I think you should cache everything all the time as much as you possibly can. And use mechanisms like this to control it. Is there such a thing as too many layers of caching? Probably. If you go through one cache layer for this purpose, one cache layer for this purpose, another cache layer for this purpose, you're creating a very many number of hops from the client to your origin. The use case, I haven't seen that many use cases. I don't know what the critical mass is. Hopefully, whatever CDN you're talking to should be able to meet all your needs that basically you only need one layer of caching. The only time that we see multiple layers, in our case, because we use Varnish, and Varnish is a very popular technology inside data centers, is we have a lot of people that have a Varnish layer that front ends their origin infrastructure, and they use Fastly as a second layer of Varnish out and about, essentially. And they have interesting sort of decisions to make because there's some logic that you can share between the origin, because you have the same infrastructure as we do, and our caches. But that's only our use case. There's others that I'm sure handle it differently. That's the only way I've seen multi-layer caching. Okay, the question is, how do you serve content on HTTPS, or how does CDN handle HTTPS? So it should be the exact same paradigm. Just the communication protocol is secure. I didn't use HTTPS in any of the examples because it doesn't actually change the flow at all. But a CDN should be able to serve certificates from here and terminate SSL connections. And if you choose, this communication between the CDN and the origin should be encrypted if that's how you prefer to deploy your site. So any CDN that you use should be able to do SSL on both
I
sides.
think it all ends up being like preference. Some people really like to have everything secure end to end. Some people are okay with their CDN not talking to them because the CDN is going to come to them maybe through a handful of cache nodes that you know, like we can tell you, CDNs can tell you where those are. Maybe you're okay with not having SSL there. Maybe you don't want to pay the SSL overhead at home, and you are okay with having clear text between the...
Yeah, if it's not, so for example, we have customers that only open their firewalls through our IP addresses, and only we are allowed to go in. But still, it's a clear text communication if that's what they choose. So I found it that it's just generally a preference thing, but any CDN should be able to offer all the mechanisms, any combination.
Is it true that SSL, are you planting a question? Is it true, the question is it true that SSL is always slower than no SSL? I'm sure there's data that says one way or another. I have personal opinions that I don't necessarily want to inject into this conversation because we're going to talk about HTTP 2 next, and that's going to be a whole can of worms. What I can tell you is that HTTPS handshakes are certainly more expensive than non-HTTPS handshakes because you have more round trips, because you need certificates to come down and all these sorts of things. If you're using a CDN, I can't talk about it now, but you look for a mechanism called false start. So this is a mechanism that essentially reduces the round trips by 1 for SSL handshakes. It's a sort of a shortcut. Most modern browsers support it, but not necessarily every server supports it. And I'm not sure if every CDN supports it. So make sure your CDN supports something called false start, which lets you at least shave a whole bunch of latency and round trips from the handshake. The actual the encrypted communication itself is, I think, at a point where symmetric encryption isn't that much of an overhead anymore, but I'm sure if you sat there with a really, really special tool, you'll find little pieces where SSL will be a little bit slower. I think we can say that it's not faster, but whether it's slower or not, I think it will depend on your tools and how calibrated they are. Any other questions? Well, this was very long. Thank you for bearing with me for this very long presentation, hour 15 minutes. Thank you very much.